Hello everyone, welcome back to the latest lecture session. I believe we've been discussing summarizing some aspects related to wastewater treatment plant. Or wastewater treatment in general, pardon me. Were not discussing about any particular plant. So today we'll discuss about some aspects related to wastewater, and then we'll discuss about our treatment plant at IIT Roorkee. If we are unable to take you on a visit there, which was the initial plan, we will record a video there, and we will make you understand how things work, right, so that you see how important it is. So let's get this going. Typical sewage treatment plant, what do we have? Typically, most of our sewerage network is blocked because of plastic. I guess all or quite a few of our citizens, they dump plastic into the drainage, and plastic, it's not degradable, it's not soluble, right, it's going to block it up, and that's why much of our infrastructure is typically under pressure, let's say. And again, to remove that so that it doesn't interfere with the operations and machinery downstream, you have to remove the plastic or such bigger material out here, and then grit chamber where typically sand and such heavier particles are allowed to settle down, and settled, what do we say, material, depending upon the type of waste, it can go to a landfill or is sent to compost for further treatment. Primary clarifier. So typically in wastewater, they do not go for coagulation and flocculation, because if you do so, a lot of the organic matter is going to settle down, some soluble adsorbed onto the sediment, and a lot of the sediment is going to settle down. So, and then you are going to have issues with treating all the settled organic matter, right. Again, that is going to create a nuisance. So, typically whatever settles by gravity, they might let it do so, or sometimes people even skip primary treatment once they have the grit chamber. But again, coagulation and flocculation typically not very much practiced in wastewater for these reasons, let us say wastewater treatment. And then what do we have after we remove? What are we trying to remove in this particular primary treatment? Suspended solids. Suspended solids will also have some what do we say, organic material, obviously. So thus the overall BOD will decrease, but the soluble BOD will not decrease by much. So the soluble BOD, meaning this organics which are soluble, right, we are going to remove them by a biological treatment. As discussed earlier, how are we going to do that? By microbes degrading this particular organic content, right. And what do they need? They need an electron acceptor, which is air. That is why air, and thus high electricity or energy costs, right. So this is what we are trying to achieve, let us say, with respect to, and this reaction is catalyzed by the microbes, which secrete enzymes, let us say, which catalyze this reaction, right. So what do we have here? Aerators, and then the reactor here, typically retention time can be 8 hours, 10 hours, 6 hours or such, depending on the type of system. And then secondary clarifier. Why the secondary clarifier is that, the microorganisms which feed on this particular waste, they change into different kinds, let us say. And one aspect that I need to point out is that the microorganisms that thrive here typically kill almost all, or most rather, of the pathogens that come in via the wastewater. Okay, that is one thing to keep in mind. The pathogens are going to be, I guess, they are not going to survive this what do we say, environment where different kinds of microbes thrive, let us say, right. So that is something to keep in mind. Quite a few or lot of the pathogens are killed here itself. And then these what do we say, microbes, after aeration, they are taken to a secondary clarifier. Secondary clarifier means you do not have any mixing, whatever can settle will settle down. So the flocks, the microbes that now form flocks, they settle down, and the clear water above is sent out for discharge or disinfection, let us say, right. So that is something to keep in mind. But what about this sludge? Again, this is also organic matter, the microbes. So some of it is sent back because your initial wastewater does not have, or influent wastewater does not have enough microbial content for this particular reaction to go through within a limited period of time, right. So, what do you do to increase or fasten the reaction? You are going to add microbes, and where are you going to get the microbes from? From those that have settled out here. And some of the microbes or sludge that is not required to be recycled, it is going to be sent to an anaerobic digester. And from here, as we mentioned, it is anaerobic digestion, so mostly CH4 and sometimes CO2 depending on the efficiency of your process. So, and the CH4 or such can be, what do we say, used for electricity or generating electricity. But the key issue here is that for this plant to be efficient or such, you need it to be what is this now, for energy recovery from an anaerobic digester to be efficient, you need plants to be at least 50 MLD, million liters per day or such. If it is less than that, I came to know that the energy recovery, from what do we say, a kind of energy recovery devices or such which can generate electricity, they are not pretty efficient at low, what do we say, loadings, let us say. So, if any entrepreneur wants to look into it, this is one aspect to keep in mind. For example, why I say so is for IIT Roorkee, the treatment plant capacity is 3 MLD. So, obviously having this particular system is an issue. So, again that is one aspect to keep in mind, let us say, right. So, let us move on. So, pre-treatment of industrial wastewaters, as we talked about, one industrial zone is near us is in Bahadrabad, which is downstream of Haridwar, right. Industries, obviously you need people, what do we say, to be employed. Employment, industrialization, they go hand in hand, but obviously the environment is a key underlying factor always. So, industrial wastewaters must be pre-treated prior to being sent to common effluent treatment plants, right. So, for example, in this Bahadrabad industrial area, we have one common effluent treatment plant, right, but the industries are supposed to pre-treat it and send it to this common effluent treatment plant, but rarely do they do that. Why is that pre-treatment required? Because again, industrial waste, they are not biodegradable. Some are remarkably toxic, and without some level of treatment, let us say, these wastes, when they come to this wastewater treatment plant, they create havoc, right, with to the microbes or to the microbial community there, and the system is going to fail. And keep in mind that these are not chemical systems or such, but biological systems, let us say, and it takes months for the system to set right. So, when you talk about industries and such and effluent treatment plants being set up, please be what do we say, knowledgeable enough to question what kind of plants and will it meet the relevant purpose, right. That is something to keep in mind. And obviously, the local authority must monitor and regulate industrial discharges, but as we talked about, the local authority either not very much knowledgeable or more importantly, they are understaffed, let us say. Pre-treatments requirements are set by MOEF. Let us move on. Secondary treatment, what are we trying to achieve? So, during primary treatment, mostly we are trying to remove suspended solids, but there will obviously be organic matter in suspended form, and along with this flocks or the flocks that are being settled out in primary treatment, some soluble organic matter will also be removed. But we are primarily still concerned with a lot of organic matter which is dissolved, let us say, right. So, we are trying to remove soluble BOD, and if there are any other suspended solids, that is one aspect, I guess. As we discussed earlier, organic carbon plus O2 goes to CO2, right. And the issue here is that, I guess we talked about this, we know that if you dump the waste in the river, right, at this point, what is the DO profile going to look like? Something like this, or rather it is going to be like this, right, DO profile, let us say, dissolved oxygen profile. So, you do not want this to occur. So, the BOD which would be degraded like this, I guess, instead of this BOD being degraded in the natural environment, you are going to recreate the environment in the wastewater treatment plant. So, that is what it is we are trying to do, right. So, again, how is it that we can do this? We want to create an environment where a diverse microbial community can thrive, let us say, right. Both what is this, different kinds including filamentous too, but though a lot of filamentous not good too. Again, we will not go into that detail. And we will, what do we want? Obviously, high concentration of microorganisms. So, think of this, the organic content or BOD as we call is the food to the microbes. So, just a limited amount of microorganisms, they will take a lot of time to consume the food. So, that is why we are trying to increase the concentration of the microorganisms, let us see. and obviously good contact between organisms and waste, that is why we provide mixing, and we need an electron acceptor for the microbes to degrade your organic content, that is why aeration. Obviously similar to us, let us say they need temperature, pH and nutrients, let us say, right. And as discussed earlier, again similar to humans, they also do not want to be put in a remarkably toxic environment, let us say. That is why we need to control industrial inputs. So, different kinds of what do we say, wastewater treatment plants, most often than not in India and abroad, typically activated sludge process, but now people have moved on to, or rather have started moving on to, sequential batch reactor. Please note that sequential, in sequence batch reactors, let us see, right. Typically all these wastewater treatment plants are CSTRs, but now keep in mind that this is a sequential batch, right, reactor. And some cases when the relevant organic content is very high, you are going to have anaerobic process like upflow anaerobic sludge blanket reactor, but again it is rarely used for municipal wastewater treatment, but I believe in Kanpur they have a huge facility that runs on this. But for low strength wastewaters this is not good, but for industrial wastewaters with less toxic compounds and what do we say, ions, this is pretty good, let us say. But maintaining this and running this is a huge challenge, but energy can be derived considerably from these kinds of plants. But again we are talking about 50,000 or so BOD, I guess, right. And let us move on. Activated sludge, right. What is this activated sludge? As in when we talked about this wastewater treatment plant, what did we see? We have this where the air is bubbled through, right, air is bubbled through, and after the microorganisms degrade the waste in this particular aeration tank, they are sent to settle down in a sludge. So, all the flocks are such, they settle down, and this sludge, though it is not entirely sent to waste or for treatment, some of it is recycled back. So, it is activated sludge process. When we say sludge, it is nothing that but recycling the microbes, let us say, right. So, that is what we have, leads to oxidation. So, I guess we already discussed this. So, typical STP, so suspended solids, organic content, and if required nutrients like nitrogen and phosphorus, but we have not discussed tertiary treatment here. So, but typically the costs, let us say, are considerable. Let us say, I think very rough estimate maybe, but depending on obviously the size of the plant, 1 crore per 1 MLD, million liters per day, right. Again that is a very approximate number, and if you look at it, maintenance costs are also considerable, and most of the costs, let us say, if we are talking about percentage of total energy requirement here, is due to the air that has to be pumped into your what do we say, to keep your microbes or to give the microbes enough oxygen, right. So, that is something to keep in mind, that oxygen levels obviously are the key, similar to our what do we say, requirements, let us say. So, here what do we have? We, as we discussed, we talked about sequential batch reactors, and as we mentioned here, sequential batch, what do they do? It is more or less, combining all these processes, unit process, we call each of these unit process, right. So, equalization, primary settling, biological treatment and secondary settling all happen within the same tank, right. It is a modified activated sludge system, where a single tank without any primary or secondary clarifier, because it is like a batch. First you will have, let us say, aeration, then you will have settling and so on and so forth in the same tank, let us say. Space requirement is less, that is why it is relatively popular in India, and also nutrient removal is possible depending on how you are going to maintain it, and this is what we have at IIT Roorkee, let us say. And I always talked about settling of flock after aeration. I think I have a few pictures here. So, this is the sample that we collected from these tanks right after aeration or during aeration, not after. And this is the flock that I am referring to, right. At the last stage of aeration, this is what we have. The microbes are well fed, organic content has been degraded, and now the microbes, they form such flocks. Hopefully that is clear to you. And from the side view, if I let it settle down after some time, so you see that the sludge is settling down, obviously because it is heavier, and now I have the relatively clear water which is going to be sent out, let us say, right. So, again I believe this is not believe, it is the same unit process chart that we looked at earlier with respect to IIT Roorkee. So, I will not look at that. So, this is the inlet, that is what our sewage looks like, feces, urine, bathroom, kitchen and bathing water, everything I guess, right. And outlet, this is what it looks like, right. So, I believe I am now at the end of my presentation. And the sludge, we want to compost it, but first with respect to before composting it, you want to decrease the water content, otherwise it is going to be heavier to transport and also difficult to degrade. So, that is why you dewater the sludge and then send it to what is this now, to various not various, for composting I guess. Low tech solutions practiced earlier, but typically they do not work, take a lot of area and also efficiency is less. It is waste stabilization ponds. What do we have here? So, here we have waste that are just let to stay in these ponds, where in that zone which is far from the surface, where oxygen transfer will not take place, you will have anaerobic degradation. In the zone that has some oxygen, but not a lot, you will have what is called an anoxic zone, where oxygen will be derived in the form of or be available in the form of NO3, or the electron acceptor is going to be NO3 minus. And then you will have an aerobic zone where the traditional aerobic degradation is going to take place, and the what is it now, oxygen from the atmosphere is going to be taken in. But again these were used earlier, but the issue is that they will leak, leading to groundwater pollution, and more importantly a lot of area is required, because here the microbial concentration or community concentration is less, because we are not recycling the sludge or such. So, the time required will be a lot, and also efficiency is relatively less, but obviously it is cheap, right. But you can't have acres and acres of land, let us say in Delhi, Bombay or such, it will not work that way, right. So, hydraulic retention time as we see here is 180 days or such, 830 to 180 days. So, you can look at the area, and theta for SBR and such, let us say is 4 hours or so, let us say for your SBR plant, let us say 4 hours. So, that is something that you can what do we say, consider. So, I believe what is this of a facultative lagoon pond, again sometimes if they do not maintain it well too, but again this is more or less a repetition of what we have earlier. So, carbon dioxide and light, algae, organic compounds and oxygen, oxygen coming from the algae out here or from the surface, carbon dioxide is released and organic compounds are degraded. Here it is the anaerobic zone I guess. So, one aspect is that people do also maintain these ponds pretty well, but again efficiency is less. So, low strength wastewaters, yes. Here we are looking at one success story, the miracle of Kolkata's wetlands, and one man struggled to save them. And the person says that, again keep in mind that you will always have drawbacks, but you can make things better based on what tools are available to you, let us see. Here they made the wetlands work. The wetlands are the Indian cities, meaning Kolkata's free sewage works, a fertile aquatic garden, and most importantly a flood defense. This is true though, right, a flood defense. But they are under threat from developers, this is always the case, and a person is leading the resistance, let us see, right. Cities free sewage networks, as in they act as your stabilization ponds, and they are also good for your aquatic markets, let us see. For example, typically now you might have seen hydroponic what do we say, agriculture or such, where there is no land and you have your plants being fed on different kinds of partially treated sewage, let us say, right, and the plants take the nutrients from this particular sewage and they grow. Again entrepreneurs, you can look at this. And then fish, obviously they will not survive well in Divu, but again you can look at some of the relevant information, but we discussed this in some detail. But again this is for people with no background, but once you read it you will understand the drawbacks here too, right. So, again what do we want to do? This water we want to treat it in our sewage treatment plants, and then we are going to release it such that the BOD is 30 or now 10. In IIT Roorkee we can achieve 7 to 6 milligram per liters of BOD in our outlet, and rather than going through this and due to direct dumping, we are going to directly, let us say, be in this phase most of the time, right. So, I guess with that I will end today's session, and we will move on to looking new aspects from the next session, and thank you.